Now we're going to test some specific triangles to see if we can say that they're similar. I'm just going to do a few examples. So, looking at number 1 here, I can see that I have a right angle in each triangle, so I have a single angle. 40 isn't the same as 50, so I can't say angle, angle off the bat. However, I know that all the angles in a triangle have to add up to 180, and this right angle is 90. So if I have 90, let's look at the smaller triangle. If I have 90 plus 50, that's 140. And 180 minus 140 equals 40. So this angle right here has to equal 40. So now I know that angle B is congruent to angle Z because they're right angles, and I know that angle C is congruent to angle Y. So I can say angle, angle similarity. And I can say ABC is similar to X, Z, Y. Be careful about the order. Looking at number 2, I see that I have a couple of parallel lines, so that's useful. That can tell me that this angle at H, angle GHJ, is congruent to angle GMK, because those are corresponding angles. I can also say the angle GJH is congruent to angle GKM. Alright, so I've got two pairs of angles, that's all I need. So by angle, angle similarity, I can say that GHJ is congruent to triangle GMK. Alright, this one I don't have any angle information, so I'm going to have to rely on the sides. And since I don't have any angles, I have to check all three pairs of sides. I'm just going to start with the shortest one. So I have a 10 over here. The shortest one I have here is 16. So 10 over 16. 2 goes into both of those, so that reduces to 5 over 8. Okay, the middle sides, 15 and 24. 15 divided by 24. 3 goes into both of those. That's 5 over 8 again. So far, so good. And the longest side, 20 and 32. 20 over 32. 4 goes into both of those. So again, that's 5 over 8. So it checks out. So FG is similar, it's proportional. I can't say it's congruent, but FG goes with SX, okay? GH corresponds with XR, and HF corresponds with, let me make sure I get this right. Oops, did I do this wrong? I'm sorry. GH actually corresponds with RS. So let me just correct that. RS. And HF corresponds with XR. Okay, so I can say that these are similar using side-side-side similarity. And let me just make sure I get things in the right order. So if I start at F, the one corresponding to that is X. The angle corresponding to H is R. And the angle corresponding to G is S. So there's my similarity statement. All right, I'm going to check a couple more and then we'll be done. So, I have some information about sides here. I also have one angle I can say because these two triangles share an angle. So I do have an angle at P. So if these two are similar, I know, since P is first in that triangle, I know it's going to be triangle P something something. All right? So luckily everything's lined up, so I can say 4 to 12. Figure out what that ratio is. Well, 4 goes into both of those numbers, so that's 1/3. And 7 out of, I don't know the full side. But I know that part of it is 7 and part of it is 14. If I add those together, I get 21. 7 out of 21 equals 1/3. So that checks out. So I can say that this is a similar case by SAS, because I have a side, an angle, and a side. All right, so angle P corresponds with angle P. Angle Q corresponds with angle U, and angle R corresponds with angle V. So I can say triangle PQR is similar to triangle PUV. Last example. I have some proportional sides. I also have some vertical angles here. So I definitely, if they're similar, they'll be similar by SAS again. So I just need to check. So the shorter side of this top triangle is 21. The shorter side of the bottom one is 34. 21 over 34. Okay, I don't think that reduces, but if I plug it in, I get this is equal to 0.6176. Now here comes the danger in rounding. If you guys are rounding things off too closely, you might get messed up on this. Let's look at the other side. 36 and 59. 36 divided by 59. Again, that doesn't really reduce. When I plug it in, I get 0.6102. So again, if you guys are just rounding to 1 or 2 decimal places, you'd say, oh, that's equal to 0.61. Oh, the ratio is the same, they're similar. But they're not, because this is not the same as this. You can only say that they're similar if you get exactly the same simplified fraction. So we cannot say that they're similar.